Okay, guys, welcome back. I hope you had a good long Labor Day weekend. And I thought I would do one more clip to finish our discussion on Chapter 2. That's all about chemistry. And again, we're doing just kind of the bare bones of chemistry, stuff I really need you to know. We're going to visit chemistry one more time before the end of Module 1. But let's backtrack just a second here and talk about what we've seen when we're looking at these large organic compounds. Organic, they have a carbon in them, right? They are compounds that are very large. We have our carbs, we have our lipids, we have our nucleic acids, and our proteins. Now, in many of these, we have seen that there are building blocks, monomers, right, that make each one of them up. So let's look at this image here. We could be talking about a monomer that makes up a protein. So this would be an amino acid then, right? Monomer 1 could be an amino acid, one of those 20 amino acids that exist. And then we'd have monomer 2, it would be another amino acid. And these would come together and form some kind of bond, right? And whatever that bond happens to be that's formed here, in the case of two amino acids, it would be a peptide bond, right? But this was not specific to proteins, just proteins. We saw these kinds of reactions taking place between fatty acids and glycerol to make a lipid molecule. We saw this between two glucose molecules, maybe, in the formation of something like a starch, which is a complex carbohydrate. We saw the same kind of thing with nucleotides coming together to make a DNA molecule in that nucleic acid category. But something that was common throughout is that a common process of dehydration synthesis would oftentimes take place in the formation of this new bond. And so this new bond forms between two monomers, and a hydrogen and then an oxygen and hydrogen from the other molecule would come together to form a water molecule, right? So dehydration, it's losing water, and there's a synthesis going on because these two monomers are being joined. And likewise, if these were to be broken, we'd see the opposite thing occurring, right? So down here, we have a dimer. It could be two amino acids again that are already joined. We have this peptide bond. And then if we add water, like they're doing here, then we could actually split these two apart and have our two separate amino acids again, or separate glucose molecules, or nucleotides, whatever compound you're breaking down, and that would be hydrolysis. All right? So there's two kind of common things going on. If we want to build up a molecule, a lot of times water will come away from that, and we'll have dehydration synthesis, and then hydrolysis would be taking place if we're breaking these down. All right, so now let's take this a step further. And by the way, enzymes might be present to help catalyze any one of these reactions, right? Enzymes will get these two monomers real close. It'll be just the right shape for these two monomers. So enzymes come into the mix as well, right, with any of these reactions. All right, now let's skip to a general definition for metabolism. And this does connect to what we just talked about. A lot of times people might have the wrong idea of what metabolism actually is. For example, people will say that I'll take myself as an example. I will eat and not really worry about putting on pounds. I'm a tall, thin guy, and I guess I'm lucky in that way, I suppose. I wasn't too happy with it when I was a college student and trying to put on some meat, some muscle. It's really hard for me to do that. But people will say I have a high metabolism because of this characteristic. And what they're thinking, I believe, is that I break things down quickly and I don't put on fat because of that. Well, the definition of metabolism is not the breaking down of things alone, reactions that break things down and break bonds. Metabolism is actually a reference to all chemical reactions that are necessary to maintain life. So that's the definition. Not just the reactions that break something down into smaller things, but also those reactions that build things up. So, definition of metabolism, a little different than what you may have come in thinking. Now, we could reference the half where we are building up. We're making bonds between these monomers, right? So here we have, again, we have the amino acids. Peptide bonds form between these, and those peptide bonds, we'll make it yellow here. These peptide, there we go, yellow. So we make these peptide bonds in between these amino acids, and that would be making it larger, right? We could refer to this as anabolism. Think anabolic steroids, right? So steroids are going to make you larger, right? You're going to put on muscle fast. So anabolic is a term for the processes we use when we're talking about building up something bigger from smaller molecules, okay? And in the example here, we're making a protein out of amino acids. Now, generally, anabolic processes will require some energy being put into the reaction, okay? So think about, let's go back here again, we see these yellow peptide bonds down here, right? Each one of those peptide bonds is a covalent bond representing a sharing of 2 electrons between some atoms there, okay? These shared electrons represent energy. Okay, so you have to put some energy in. Energy has to be put in, and and oftentimes you can think of that as electrons having to be put in to form this covalent bond. And we say that would be an endergonic reaction. Okay, in chemistry they talk about these things. An endergonic reaction requires energy to be put into the process. Okay. Now sometimes when we form new bonds and electrons are added to make this bond form, we will also call it a reduction reaction. Okay? Think about the fact that these electrons, so I'll put a small letter E here. So E for energy, okay, initially I have this big letter E representing energy being inserted, but it's energy in the form of electrons being added. So these electrons are negatively charged, right? Reduction, think about the negative charge. You're adding negatively charged things. Okay, so we call it reduction here for those electrons being added. Okay, so this is to say that there are lots of ways of talking about building something up. We could talk about dehydration synthesis, where a bond is being formed, right, and water is lost. We could say it's an anabolic process, and there's energy being put into the process in that, in making that bond. If there's a bond formed, then we could say that it's a reduction reaction, where electrons were added in the form of covalent bond. Okay? So lots of ways of talking about building this molecule up and forming these bonds. All right, now let's look at the flip side of metabolism, where we're talking about breaking down molecules. All right, so here we have a complex carbohydrate in the form of a starch molecule. You may recall that starch is made by plants like potatoes, for example, and there is a covalent bond existing between glucose molecules here. What's going to happen in the process of breaking down? We're going to break those bonds. And remember, I'll put this in here just to remind us, that these covalent bonds represent a sharing of 2 electrons in every case, at least 2 electrons being shared with a covalent bond. Okay? Now, this would not be anabolism. This would be the flip side, catabolism. Think cut for cat, right? Cutting something down. Catabolic process is going to break down large molecules into small ones. We could just as well have been talking about peptide bonds being broken here, but they chose a different organic compound in this image, okay? Now, Here they're showing starch being broken down. We could think of this as when we break this bond, there's electrons are going to be given off, right? In this case, it's going to release energy, okay? So if I break this bond, we're going to release energy. Energy doesn't have to be put into the process, it's going to be released, okay? Also, you can think about the fact that the release of that energy might involve the loss of those electrons that were once there in that covalent bond, okay? So the loss of those electrons that are being given off as a result of breaking that bond would mean that we have an oxidation process going on. Electrons are lost as a covalent bond is broken. All right, so for catabolism, for this breaking down, we could talk about hydrolysis, where oftentimes a water molecule is going to be added to help to break that bond. We could talk about them as catabolic processes, cut for catabolism, right, breaking it down, where energy is released as a result of breaking that covalent bond. And electrons would also possibly be released. Oxidation. All right? So that's kind of the overview of some of this metabolism that goes on, how it is we break bonds or make bonds. We're going to have to keep this in our back pocket for a little bit later when we talk about some really important reactions that occur that we're going to have to know about for this first module. Okay? We'll leave it at that, and we'll launch right into the cell in our next clip. All right?